Okay, folks, a short video of the examples in lesson 9.2, law of sines, law of cosines, some area formulas. Here we go, example. Okay, example 1. Now this has to do with the law of sines. Let's review the law of sines. A over the sine of A is equal to B over the sine of B, angle B that is, and that's equal to C over the sine of C. I'd like to do a video on deriving this, but it's in the book. And keep in mind, I always draw some type of triangle here. A, B, C, and this is little a, little b, little c. Okay? All right. So what they want you to do in this picture is they want you to solve this triangle. Now, what I'm going to do is I'm just going to redraw it. Okay? I'm going to call this A, I'm going to call this B, I'm going to call this C. And I'm going to make my little legend down here, ABC and ABC. Let's go back to the picture. They gave you that this is 50 degrees, okay, and they gave you that this is 10, and then they gave you that this angle here is 30 degrees. Now, it's not to scale, but you get the gist of what I'm talking about. This is little b, and this is little c. That helps you keep track of your triangle. You know what I would do is I would write in here the values that you know, okay? Okay, now I've got to find b and c. I found angle c because, you know, it's 180 degrees. B and c. So I'm going to use this ratio idea. And I'm going to start with a pair. That's the key with the law of sines. Now, I put the side on the top. You could put the side on the bottom if you want to. So 10 over the sine of 50 degrees is equal to, in essence, it really doesn't matter. I'm going to pick the smaller one, b over the sine of 30 degrees. Okay, now, let me do this the first time, just one time. I'm going to have to multiply b times the sine of 50, and then 10 times the sine of 30, which means that b is going to be equal to 10 sine of 30 over sine of 50. Now, when you put this on your calculator, I would do 10 sine of 30, you could hit enter, divide by sine of 50, or you could do it all at one time. But if you do it all at one time, make sure you finish your parentheses there. So bottom line, when you do that and work that out, you get 6.53. So B is 6.53. Now before I do anything else, I'm going to put it right here in my little key. Now we have to find C. Now we know that we have a pair. We're going to go back to our original pair. 10 over the sine of 50, okay, is equal to what we're looking for. We're looking for C, but now we know the angle. Okay, so again, what I'm going to do is I'm going to take my calculator, I'm going to multiply 10 by sine of 100 and divide it by this. And C is going to be equal to 12.86. 12.86. I'm going to put it right here. Okay, remember, I round to 2 decimal places on my side, to 1 decimal place on my angles. Now, someone says, is there a way to check this? Here's an informal way of checking it. Pick your smallest angle and then see if it's across from the smallest side. Pick your largest angle and see if it's across from the largest side. Okay, that would be my advice. Okay, let's look at example 2. Example 2, okay? In example 2, they're talking about some type of UFO, and they want to know, they want to know what the height is of the UFO. Notice the triangle. Always draw the triangle. Also, this 20 is, we don't know how much of the 20 is on each side, so that's not going to help us out a whole lot here. But one thing that we do know, we have this big triangle, and we could use the law of sines in the big triangle. So I have C over the sine of C is equal to A over the sine of A. All right, so here's my 20 over the sine of 130 is equal to a over the sine of 35. Remember, we're solving for a. So to solve for a, we go 20 times this on our calculator and divide by this, and I get a is 14.98. So notice I redrew the triangle here. Okay, can I find h now? Well, yeah, because I know that sine of 15 degrees is equal to opposite over hypotenuse. Okay, we've done this before a few times, so just go like this, cross multiply. H is equal to 3.88. And again, I round this way. Okay, hope that helps you. Okay, folks, this is example 3. Example 3. And what we're trying to do here with this example is solve the triangle. Solve the triangle. Let's redraw it. Okay, this is A, this is B, this is C. We're going to call this 85. We're going to call this little b. We're going to call this 12, and we're going to call this A. Okay, so we set up our key, and by the way, this 9 was included for B, so I included that in our key. Now remember, to solve using the law of sines, you need a pair. So 12 over the sine of 85 degrees is equal to 9, that's the only thing I can use, over the sine of B. Now please keep this in mind, you're solving for an angle now. Well, to solve for the sine of B, we're going to have to do 9 times the sine of 85 degrees over 12. But remember, whatever we get with our calculator, let's call that answer, okay? That's just the sine of B. So to find B, we have to do inverse sine of the answer. And when we do that, we get B, 48.3 degrees. Okay. Now keep in mind, when you did that, it was a positive value, so sine is positive here and here. It could have been an obtuse angle. Just kind of keep that in mind. That plays into some of these problems. You don't have to sit and worry about it. All right, so here we have 46.7 degrees. So now we have all the angles. Got to find little a. Again, law of sine. Little a over the sine of 46.7 degrees is equal to, I would always go back to what was given you, values that are clearly accurate. And when I do that, I'm not going to insult your intelligence here, okay? We're going to get, what are we going to get? We're going to get 8.77. So that's going to go here, 8.77. Again, check smallest side, is it across from the smallest angle? Largest side is across from the largest angle. Solving a triangle is a very important idea. Okay, find all possible triangles if one side has length 4 opposite an angle of 50. I'm just going to set it up this way, that 4. And the second side has a length of 10. I'm going to put that right there. Now, just for the sake of argument, I'll call that A. Now, one thing we do know that the sine of A is equal to the opposite in this right triangle over the hypotenuse. Well, hey, that tells us something. Sine of 50 degrees, which is angle A, is equal to h over 10. Cross multiply, we did that already. So h is equal to, put that in your calculator, and you're going to get 7.66. Now just hold the phone for a second. This side hanging here, 4 is less than 7.66. There's no way that you are going to make a triangle, and that is called no triangle. So there's no triangle that could be formed with a triangle with those kind of dimensions. Now watch my video on setting up the ambiguous case, and you'll know more about why this works out the way it does. Okay, example 5. Find all the possible triangles if one side has a length of 6 opposite an angle of 50 degrees and the second side has a length of 4. So I set this up, and here we got h is equal to 3.06. Well, one thing we know for sure, 6 is greater than 3.06. So we're going to have a triangle somewhere. But there's no way that you're going to be able to make that 6 swing over here to this 4 side. That makes no sense. So we know that 6 is greater than 4. That tells us there's only one triangle. Now what is that triangle? Well, we're going to have this angle 50. And then we're going to have, we have the side 4 here. Then we have the side 6. 6 is going this way, okay? I'm going to call some letters out. Let's just say A, B over here, and C, okay? And the question is, can I solve that triangle? Good question. Okay, we're going to have to set that up like we did the last time, and when we put that on a calculator, we get 30.7 degrees for B. Okay, and then when we use what we know about triangles, C is 99.3, and then we're going to have to set up another law of sines to find the angle. Okay, remember how to do that on your calculator. This times this divided by that will give you C, 7.72. 7.72. Now check, is 4 across from the smallest angle? Is 7.72 across from the largest angle? Okay, keep that in mind. Okay, this is a question about the law of cosines. Now, according to your green sheet, there's several ways of variations of the formula. Now, this is how I do the law of cosines. Big angle P, little p, A, and B. And this tells us that the little side squared is equal to the other side squared that form that angle P minus twice their product times cosine of the angle. Again, you could use whatever formula you want to on the green sheet, and I posted this on the green sheet for you. So I'm trying to find X here, which is the distance from port to where the boat ended up. Okay, now I know that on a linear pair from high school, if this is 20 degrees, that's 160. So here's my triangle, and notice I do not have a pair. So I'm going to have to use the law of cosines. The little side squared is equal to the sides that form the angle, 8 squared plus 10 squared, minus twice their product. Well, that's 80, okay, times cosine of the angle. What's the angle? 120 degrees. Now, having done this many, many times, my advice is just very simple. Just do the right side on your calculator the way it's written, and you're going to get some kind of answer, okay? Then for the next step, just take your calculator, do the square root of the answer. Remember, answer is a special key on the calculator. When you do that, you have 17.73 miles, okay? That makes sense. So that's how you do this particular problem, which is example 6 on 9.2. Without trying to rush the other problems here, I'm just going to put those problems on a separate video. So this will continue on to 9.2. This is A, so 9.2b.